Hello guys, welcome back to the new tutorial. In today's tutorial, we will make Phoenix International Media Center all parametrically. Anyone who wants the final GRasshopper script just keeps watching this video. You will find out how you can get for free. Let's open up GRasshopper and start. As you see here, the cross section is an elliptical shape. What we could do is make a circular curve, then we can place ellipses on it. The base form is almost circular, so I use circle. You can use any type of curve, either draw on Rhino or make it in GRasshopper. So search for circle node and connect number slider. Now I can control the size of the base form. Next, we're going to place ellipses on this circular curve. So we need to make planes on this curve. I use perpendicular frames. This helps me to generate a number of equally spaced perpendicular frames along a curve, so I can place the ellipse on each of them. Now I can connect ellipse to this. You can control size of ellipses by R1 and R2. To make the form look twisted, we need to rotate these ellipses gradually from 0 degrees to 180 along with their corresponding planes. This means the last one rotated by 180 degrees and the middle one rotated by 90 degrees, and so on. To do that, I can generate a range of numbers between 0 to 180 using range node and connect to rotational angle. Here I'm checking the length of list on the ellipse and range of numbers. As you see here, the list length of the range is greater than by 1, so I add expression -1. This keeps from duplicating the last ellipse. Now we can create a base form by lofting. In loft option, check closed loft, align section and rebuild. When you change the number slider, sometimes you get weird results. To fix that, I decide to align the section by myself. I need to place each seam on the bottom of the curve. So by using a bounding rectangle, I can get the base of each ellipse and then create a plane in the center of it. Next, find the intersection between the ellipses and these planes. This will give the parameters at which point they connect. So I can shift the seam to this position by using component called seam from Pufferfish. Next, move each ellipse in the z direction until their base reaches the xy plane. We can use the z coordinate of the intersection point. This gives the distance below xy plane. It's a negative value, so add the expression -x to change the sign. Next I'm going to create a diamond grid on this surface. Diamond tiling from Mesh Plus plugin. Set odd numbers for U and V. This makes perfectly fit grids. To make the grid structure, I'm going to offset this mesh in both sides so I can create loft between them. Next, extract face boundaries. For each face, we need only one edge, so explode and choose one item from each group by list item component. Next, remove the last branch. You can use trim tree or shift path. Flip matrix to change list direction. Now we have two curves in each branch, so we can make loft between them. For fast computation, I use mesh loft. Join and wheel from Weaverbirds plugin to join all separate mesh into one. To smooth this up, I can use sub D from mesh and convert back to mesh and give thickness. You can also give thickness to sub-D object using GHPython script. You can leave this process, search GHPython and connect sub-D to X and number slider for Y. Make sure you set type hint to sub-D and float respectively. This helps GHPython to easily understand. Next, open script editor by double-click on the node and type this. Now you can control thickness of the sub D using number slider. Next, we're going to make these pipe-like structure. By offsetting the original mesh, we can control the location of the pipe where it should be. Next, I'm going to extract one of edge form the each mesh face. I can use the previous node by copy and paste. Join these curves and make pipe using mesh pipe from Chromodoris plugin. To smooth this up, we can use mesh from sub D, or you can use Weaverbird's Catmull Clark component. Let's see the preview by using custom preview component without baking. Here these grids are crossing, so increase offsetting value by the radius of the pipe. This keeps from crossing. Okay guys, the first 30 people who leave a comment on this video will get the Grasshopper script. Anyone who wants just leaves any useful comments on this video and click the first link in the description. Next, we're going ahead to make each panel. The panel are a little bit inclined, so we make parameters that control the inclination. Explode the mesh so we can get each face separately. Next, rotate each panel on one of the edges as a rotational axis. By extracting one edge from each face, we can get a rotational axis. We can use the same process previously used by copy and paste. Give thickness from previous node setup. Next, by using curve attractors, we can deform our form into this. Draw curve attractor in Rhino and reference back to Grasshopper. Our goal is to divide the ellipses and move a point in the direction respective to the distance from the curve attractor. The points that located in far distance not move and the closed one will move. So we measure the closest distance to the curve using pull point component. I use the minimum component to clamp distance value that is greater than B input. This helps to limit the influence radius. Next, by using remap number, we can scale or value to target domain. Now we can create a closed interpolate curve by using these points and replacing the previous ellipse with it. You can add multiple curves as attractors. This is final result. Thanks for watching. See you in the next video.